Okay, here we go. Today, or whatever day it is, we are going to be talking about statistics. I think we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 2-point questions and 3 4-point questions. There's never been a 6-point question. Now, these are all the statistics part 2s, 3s, or 4s that have been on New York State Regents exams for the last, since 2010. Since all of them. So what if you don't try these on your own and work on these on your own, then you're not really doing yourself any good. So you can do one of two things. You can download and print this document, or you can just hit the pause button, try it on your own, see how you do, and then come back and watch the video and see what you do. If you want to download the videos, what you do is simply just go over to my website, click on Regents Review. One of these will be, I don't know if I'm going to do a topic review or topic review is just my own stuff. This right here is all of my own stuff. I have one more video to make. I keep talking about that. Trigonometry. I still haven't fixed that spelling. And I might do it, Regents questions broken down or broken down Regents questions. But anyway, most of what you want is right here underneath Regents Review. If you're looking for all the old Regents Review answers, they're right here. Again, it's MrKrausemath.com. It's very simple. There it is. Very simple to get to. All right, you can also go to my YouTube channel. But if you haven't tried these on your own, you're doing yourself really a disservice, and you need to try these on your own. Okay? So let's get started to roll. If you haven't done this problem, pause it now and come back in a couple seconds. A normal distribution curve, a normal distribution of scores. So we're going to draw in the normal distribution curve. You really can only draw this in if they tell you you have a normal distribution. Not all distributions are normal. In fact, many are not. It says that the mean score of 57 falls 1 standard deviation below the mean. So here's our X bar. And a score of 81 falls 2 standard deviations above the mean. So what I have here is this is 1 standard deviation, and from here to here is 2 standard deviations. So from 57 to 81 is 3 standard deviations. Let's see, 81 minus 57 is 24. So if I take the difference of those two and I subtract, I get 24 divided by the 3 standard deviations, I get 8 is our standard deviation. All right, so from here to here they went down 8. Here to here they went up 8 and up 8. Now what are we looking for? We want to know what the mean score of this data is. So I just take 57 and I add 8 to it, and I get a mean score or an X bar of 65. Done. Problem's bodied. Over. All right. In a certain school, the heights of the populations of girls are normally distributed. As soon as I see the words normally distributed, I can draw in my normal distribution curve. So let me do that. Try to do that accurately. It said they have a mean height of 63 and a standard deviation of 2 inches. So I'm going to immediately go 61, 65. Now it says if there are 450 girls, determine how many are shorter than 60 inches. Well, I don't have 60 inches on my graph yet. I need to get that. So that's the next piece of information I want to get. So if I go down one more standard deviation, which is down another 2, I'm at 59. But that's not got a 60 on it. I need 60 on my graph. So 60, if you'll notice, is right here in the middle. So I am talking about all the girls shorter than 60. That's all of these girls down here shorter than 60. Oh my gosh. So I go over to my formula sheet. Why are you not expanding? And I say, okay, I need all of them. Let's see, how far did I go? I went, oh crud. This was down 1 standard deviation, minus 1, and then down a half a standard deviation. Now you got to be careful on this chart. I want to go down 1.5. So I'm going down 1.5 standard deviation. So what I'm talking about is all of this. I want all of this. Well, if I add all that up, That's 4.4 and 1.7 and 0.5 and 0.1. I believe it's 6.7%. So I come over here to my chart. I keep screwing that up. And I say, okay, 6.7% are less than 60 inches. Is that the answer? No, they want to know how many girls are less than 60 inches. So what I need to do is I need to take 450 girls and multiply by this as a percent, 0.067. And if I do that on my calculator, 450 times 0.067, I get 30.15. And they said round it to the nearest integer, so 30 girls less than 60 inches tall. And you could have also done this. I mean, if you're a is over of person, if you're a percent person, you could have done x over 450 equals 6.7 over 100. It's the same math. It's the same math. You could choose to do that if you want. All right, I'm going to pause it before I start this next one. I'll be right back. This is just me getting coffee. I think I'm out of coffee. That's not good. All right, here we go. The following list, let me get rid of all this crap. The following list is of 12 students at Webster High School. Oh, we got a Webster High School right near us. Webster High School. 2 Websters right here. And we're going to find the interquartile range. I will show you 2 different ways to do the interquartile range. Now, in order to get full credit, this is a 2-point question. You can't just write down the answer, 5, 12, 32, whatever it is. You have to show a little work. And in this case, the work will be first telling us what the formula is. Q3 minus Q1. That's interquartile range. Then you got to find them. Well, I could find them by just breaking them up into 5 groups of 5. That's groups of, oh wait, there's 12. Groups of 6. And groups of 6. And so the median, just in case you were wondering, would be 8, but we don't have a median. But the quartile 1 is the median of this lower half, so quartile 1 is 3.5. Quartile 2 is the median of these two, which is 10.5. So our answer is 7. Now, yeah, that wasn't too bad. It was lined up already for us. We already had it there. We didn't have to worry about it. But I really suggest that you guys, that's kind of a tricky way to do it. I would suggest you use your calculator if possible. You go into statistics. You can do this on the TI-84 just as easily. And you list all those numbers out. Let's see. We got 2, 2, 3, 4. 2, 2, 3, 4, 6. Oops. 7. 9, 10, 10, 11, 9, 10, 10, 11, 12, and 14. There's the 12 numbers. You come back up here. On this particular calculator, you hit Menu, Statistics, Stat Calculations, One Variable Statistics. You click OK. You tell it you call the list X, and you click OK. So again, remember I told you the mean was 8. There it is. The median. And there's quartile 3 and quartile 1, 10.5. You take them and you subtract them. So this one, clearly we're going to basically doing the same thing. We're going to find this interquartile range. And again, we want full credit on this. So we're going to write down that means Q3 minus Q1. Well, if you're going to do that here, you can't just say, oh, there's 10, so I'll break them up into 5. And then wait, but they're not in order. And in order to do this, they have to be in order. So that would be 71, and you got to try not to miss anything. And then 2 71s, and oops, 2 71s. And then there's a 72 and a 74. And look, I'll make my 74. And then we're going to go to 75. And then after 75, we have a 78 and 2 79s. And an 83. And an 83. So break it up into groups of 5. There's 5. So the lower quartile would be 72. Notice it's actually in the middle this time since there are an odd number. Here's 5. In the middle of these is a 79. So I could go 79 minus 72 and say, oh, my interquartile range miraculously is 7 again. But I can also just come over to my calculator. Oops, don't want that. And go back in, call it X. And just type them in. And I'll type them in any order I want. I'm going to look down on my sheet so I can do this here. 78, 79, 79, 72, 75, 71, 74, 74, 83, and 71. Go into menu, statistics, statistics, stat calculations, one variable statistics, click OK. We call the list X again, click OK. Boom, boom, boom. Come down here, and lo and behold, I don't know where it happened to him. I screwed something up. Let's try it again. Menu, statistics, stat calculations, one variable statistics, one list. We called it X. Click OK. Yes, it's okay. There it is. Ooh. Oh yeah, there's my minimum. There's quartile 3. There's quartile 2, 72 and 79. I subtract those, I get 7. By the way, notice here, right here, we got 74 and 75, and the median would be halfway between those two, which would be 74.5. All right, I'll be back. Oh, you're back. You want more? You probably didn't even notice I was gone. I was gone for like 2 minutes. I got saved like every couple seconds. Ow! By the way, if you're wondering why I haven't posted videos in a while, or if you're new to my videos, gosh, that hurts. Oh, I hurt my foot. And I was on medicine, and I was like sleepy all the time, so I've been a little bit lazy the last couple of weeks. So let's get ready to roll. Shut up, you loser. I'm talking to myself. Stop whining. Let's get going. Let's see what we got. So we've got some 82 video game players. It's normally distributed. We got a mean age of 17 and a standard deviation of 3. As soon as I see normal distribution, I start looking for the information they're going to give us. So they gave us that it's a mean age of 17 and a standard deviation of 3. So I'm going to go up 20 and down to 14. The question says determine if there were 15 players. Now this is just going to be our cutoff score over the age of 20. So here's 20. And really what I want then is all of this. I want all of this. That's one standard deviation over, and I want all of this. So I'm going to come back over to here, and I say, okay, I want to go one standard deviation up. So that's all of this. And if you add all that up, what you get is 15.9%, which is why they're trying, which is kind of how they're trying to trick you. It turns out that this is 15.9%. So if you're just think, oh, is 15? Yeah. But you got to remember there were only 82 players. So what we have to do is take the 82 players, multiply it by 15.9%, which is 0.159. And I get, I believe that's 13 point something. So 82 times 0.159, and I think it's 13.038. So 13.038. So the answer is no, there were only about 13 players over the age of 20. That's the answer. Okay. So, again, assume the ages of first-year colleges are normally distributed with a mean of 19 and a standard deviation of 1. So, here we go. Mean of 19 and a standard deviation of 1. So that means this is 20 and this would be 18. Oh, well, look at that. Determine to the nearest integer the percentage of college students between the ages of 18 and 20. Well, by now you ought to know that one standard deviation and one standard deviation down and up is 68.2%. Now, if you don't know that, come over to the formula sheet. And what you'll add up is from one standard deviation down, all the way up 1 standard deviation. Now, don't go one line. Remember, one line has nothing to do with 1 standard deviation. Notice it takes 2 lines to make 1 and 2 lines to make -1. So if you add all that up, you get 68.2%. Well, clearly that's not the right answer because they want it rounded. They want it rounded to the nearest integer. So the final answer here would be 68%. Then it said to the nearest integer, find the percentage of college students who are 20 years or older. So what we want is this, which is 1 standard deviation and up. And we just did that. We said that was 15.9%. That was on the last problem. So this answer would be rounded to the nearest integer, 16%. So that's not too bad. Okay, Howard and his eggs, fish eggs. Fish eggs, roly-poly fish eggs, eat them up, yum. I think there was a song like that. Clearly, I was not the singer of that song because I'm not a very good singer. All right, don't tell my students that. They love my singing. Anyway, Howard collected fish eggs from a pond behind his house so he could determine the sunlight had an effect on how many eggs are hatched. After he collected the eggs, he divided them up into 2 tanks. Now, it should have said he randomly divided them up into 2 tanks, but if you're dividing eggs, how else could it be? Not, they all look the same, so who cares? Pretty much random. But he should have said random. He put both tanks outside near the pond. He covered one of the tanks with a box to block out the sunlight. To state whether Howard's investigation was an example of controlled experiment, an observation, or a survey. So, if it's a survey, you have to ask the fish eggs. Now, I believe actually one year I'm not going to write anything for this because my handwriting's terrible, so I'll just talk to you about it. I believe actually one year we had a kid write, it's a survey. So, clearly this student can't read or thinks that fish eggs or even the fish that hatch can have a conversation with you. He wasn't my student. I'm just going to say that right now. He wasn't my student. Then we can do an observation. So you can observe what's going on. But observation, if you're going to do an observation, you can't have your fingers in it. You can't be touching it. You can't be modifying it. You would have to actually find eggs that are in sunlight and find eggs that are not in sunlight and observe what goes on. Not collect the eggs and then split them up. As soon as you start putting your own fingers in it, then you're controlling what goes on. So it is an example of a controlled experiment because you selected 2 groups. You gave one the stimulus or the control part of it, which is the sunlight, and one of them the not control part, which is the no sunlight. And by doing that and by giving you, and then figuring, and then watching what happens, you're controlling the experiment and you're controlling what goes on. So that's the answer to that question. You would have had to write it out. I'll choose not to. Spare you my poor handmanship. I just said handmanship. It's awesome English. Englishmanship. All right, kids, we're back. Let's see. Hold on. Maybe I got to go. Yep, I'll be right back. So I'm literally going like a millisecond for you, but for me it was like about 30 seconds. Got to save it, stow it, get some work going on it. Now this is a tricky problem. So you have to understand, and you got to be, what's the word I want to use? Not a moron. You can't call me a moron. I can call you whatever I want. You're a moron. All right, so here's what you have to understand. If you can't understand frequency tables, which is what we have here, if you don't understand frequency tables, then you're probably going to screw this up. What it's saying is there is one kid that got a 96, 2 kids that got a 92, 5 kids that got an 84, and so on and so forth. So these are the scores, and here is the frequency. Now, if you had to look at this, and there were 6 scores around here, let's see, and then, that's 5 scores below, and so somewhere around 80 should probably be my average, would be my guess. I don't know. I don't even know what they're asking for in this problem. Oh, we want to find the population standard deviation. So, we want to find the standard deviation. But if my average doesn't come out to be somewhere around 80, I think I'm going to mess something up. I'm not sure. Maybe it's not. Maybe it's going to be like between 76 and 80. I got to see. So I'm going to go to my calculator, but because it's got a test score and frequency, you can put these in one of 2 ways. You can come over your calculator, Let's see. Somebody else's crap is in there. Always start with a fresh grade. Make sure you have 1.1 here. We're going to call this X and F. Now, if you don't like this, you could just put them all. I could do like 96, 92, 92, 84, 84, 84, 80. If you can't figure out how to use a two-table chart, put them all in one table, one list, and then just do it the normal way. But I'm going to do them the way they set it up. 92, 96, 92, 84, 80, 76, 72, and 68. Hopefully I got those in right. 1, 2, 5, 3. 1, 2, 5, 3, 6, 3, 2. All right. So here's the change. If you put them all in one list and you come over here to go to menu, statistics, one stack, calculations, we're only doing one variable because the one variable is the test score. The frequency is not another variable. The only time you'll do two variable statistics is when you're measuring height and weight or, something. Two different topics. So we're only doing one variable statistics. We only have one list. Now, I know that's confusing because I put two lists in there, but the X list is my X. Now notice here, if you chose to just write down all of them, 96, 92, 92, 84, 84, 84, 84, 84, 76, 77, 77, whatever, you would just leave this as one. But because I chose to put the frequency in the frequency list, I could say these are my X values, this is my frequency value. So anytime you have a frequency table, call one of them X, one of them frequency, and then you just click OK, and you get the same. You would get the same results either way. So let's see what our X bar is. I'm just curious, actually. X bar is 79.45, so it should be. And we come down to population standard deviation. Remember, this SX stands for sample standard deviation. This is sigma X, or sigma X, and this stands for the population standard deviation. So write down exactly what you see. You're going to come over here and you're going to say, sigma X is equal to, and write it down exactly. Hover and pull. You can highlight this and it'll write it down here. So 7.3653, 1967, 29197, 29197. And because it said rounded to the nearest tenth, we'll now say sigma X is equal to 7.4. And there is your answer. This shows work. This shows your answer. Got to do both. There it is, kids. Going to 4-point questions. Again, we have a score and a frequency table. So we're going to do another chart, similar stuff, but now we're in a 4-point question. So let's just call this, I'm going to call this, makes it more sense, scores and frequency. So let's put these in. 72, 76, 79, 83, 85, 83, 85, 88, 94, 1145, 1145, 753. Make sure they match. Common mistake is not putting in the numbers correctly. You should double check these problems, probably do them twice. We're going to go into menu. We're going to go into statistics. We're going to go into stat calculations. We still only have one variable. In this case, the variable is test scores. I only have one list. I call my list scores. And then here is my frequency list. And click OK. So the question says, find the population standard deviation of this data. So I got to come down and find the population standard deviation. So I'm going to write this all out. So sigma X is equal to 6.594, 6.594, 3314, 3697. Now round it to the nearest hundreds place, so I get my sigma X is equal to hundreds place. And it's this, 6.59. There's my answer. Wow, that's weird. I got 5.2 when I did it before, so I'm going to check my numbers just to make sure I'm correct. So 72.1 76.1, 79.4, 83.5. Oh, this should be 85.7, 88.5, 94.3. Big mistake, big mistake. There it is. I just made a huge mistake, and you know what? I did it twice. I didn't mean to do that. I did it twice. I did it as a practice beforehand, so I wouldn't make a mistake, and I just did that. I put in an 85 as a 75. And I was not trying to do that on purpose. I'm just saying the biggest mistake made is not typing your numbers in correctly, and I just did that. Total accident. So now, geez, I got to rewrite sigma x, and this time it's 5.168, 5.168. 17754, 17754. I say at least 6 decimals. That's good enough. R equals 5.17. There it is. If you don't have 5.17 rounded in the nearest hundredths place, you're wrong. Now what we have to determine the number of students that are within one population of the population standard deviation of the mean. So I also have to get x bar off my calculator. So I'll come back up here. X bar is 84, and they round to the hundreds, we'll round to the hundreds. 84.46. 84.46. So in order to figure out standard deviations, I have to take 84.46, and I got to go this way, 5.17, and I got to go this way, 5.17. Let me go do that on my calculator. So 84.46 plus 5.17 equals 89.63. So 89.63. And now I got to do subtraction. A little bit lazy. Minus 79.29. 79.29. Now, I know it's really tempting to round this to 90 and really tempting to round this to 79, but you cannot do that. The lowest I can go is 80 because I can't go past 79.29. That gets into the next standard deviation, and I can't go past 89. So I'm going to select all the scores between 80 and 89. So I come back up here and I say, okay, 80 and 89, 80 and 89. 80 and 89, so that's 17 scores. 17 scores is your answer. Now, just for fun though, and this has nothing to do with this problem, but just for fun, I am going to add something on this one. It also could ask you, is this normally distributed? Because nowhere here it said it's normally distributed. You could come back and say, okay, is Mr. Spears' test scores normally distributed? Well, the way you would have to figure that out is you'd say, okay, I have 17 that are within one standard deviation of the mean. So I take 17 and I divide it by how many I have. Let's see. That's 17, 21, 22, 23, 26. Wait. 17, 21. So 1, 2, 6, 11, 18, 23, 26. So there's 26 scores. I added earlier and got 28. That's what I'm like messed up with. So there's 26 scores. You say, okay, is that normally distributed? Well, you go over your calculator and you say, okay, 17 divided by 26, and you get 65.38 equals 65.38. Now again, this is just add-on. You do not have to do this for this problem. This might be if it's a 6-point question, and you'd say, if it's normal, it has to be 68.2%. Remember? And we came up with 65.38. So I would say this is approximately normally distributed. Although we would expect to see 68.2%, 65.38 is relatively close enough, or is close enough to consider this approximately normally distributed. All right, that's that. Let's keep moving. Oops, I got to pause. I'll be right back in a millisecond. You won't even know I'm gone. I hope the audio sounds good for you. I was just listening to the last little piece. The beginning of it didn't sound very good. Maybe it's just my voice. Maybe it's the fact I'm bald. Maybe it's the fact that my hair is growing so long I can put a ponytail in it right now. I do need to shave, I know. Maybe on one of these next videos you'll see me after I've groomed. All right, let's get going. Oh my God, it's a cheerleading competition. Yay, spirit fingers, spirit fingers. You guys are no fun. I was just doing spirit fingers. Thought it would be cool. Got a little freaking, a little freaky deaky there with my spirit fingers. And you're like, no, lame, Mr. Krause. We don't do that here. Whatever. 10 teams competed in a cheerleading competition. All of their scores are below. Their scores were written here. How many scores are within one population standard deviation? Wow, this sounds familiar. So we come over to our calculator. Nope. Yep. We got X. We only have to do one set of scores. So I'm going to look down on my sheet. I got to look at my sheet. Let's see. 28, 29. Oh, what am I doing? 29, 28, 39, 37, 45, 40, 41, 38, 37, and 48. So there's 9 scores. Oops, it said 10. Notice I only got to 9. Once again, I made a mistake. Oh, I think they won. All right, so that one should be 29. And then I'll just add one at the end. And we'll do that 28. Make sure I get the same numbers. But again, it's so easy to make just a dumb mistake, transpose a number wrong, switch it. Please do these problems twice. It's silly to lose credit on these. They're such easy problems. Menu, statistics, stat calculations, one variable statistic. Go in here, selecting X. Notice I'm not going to change the frequency list because it's one table. It's one list of numbers. I click OK. All right, so it wanted the population standard deviation, and there she is. So, is that what I got before? How many scores were... Oh, no, wait. This one just says how many scores are within the population standard deviation. So, I guess in this case, what we got to do, we got to do 2 things. We got to find this. X bar is 38.2. And then we got to write our population standard deviation, which is... Didn't tell us to round, so I'm going to put like 3 decimals. 5.879. 5.879. So again, I got to take this 38.2 and I got to add and I got to subtract. So I'm going to come back over to my calculator. 38.2 plus 5.878. 5.878. And I get 44.07. 44.078. And when I subtract, I get 32.32. So 32.32. So I'm going to collect the scores from 33 to 44. I can only collect 33 to 34. I can't go past this to round down because 32 is over here and that's outside of that standard deviation. So 33 to 34. I'll highlight them. 33 to 34. 33 to 44. 33 to 44. Boom, 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 boom. 33 to 44. Those 6 scores within standard deviation. So the answer is 6. Boom, shakalaka. By the way, this is, I would say there is 6 out of 10, and that would be 60%. And I would say this is not good enough to be considered approximately normally distributed. I 1 or 2 or 3 maybe away from 68, but since this one was, now that has nothing to do with the problem, I'm just putting that out there. What is the interquartile range? Again, you have to give me the formula, Q3 minus Q1, Q1. So now, Q1. So now I got to come over here, go back to my table, and I got to find Q3 and Q1. Q3 is 41, so 41 minus 37, and I get 4 was my answer. Woo! I think I'm on the last problem. Yes, it's the last problem. It's a long list. Let's see. We can do this. During a particular month, a local company surveyed employees to determine their travel, work, and times. There's 15 employees. Now, what are the chances of me not screwing this up? I'd say pretty slim. I'm going to screw it up. X. So let's do it. Right here. 25, 45, 52, 55, 59, 59, 30, 40, 35. I think this one's 8. 65, 25. 40, 29. And 37 and 55. The first test you should make sure is you only have 15 scores. Well, clearly I screwed up again. I'm not even doing this on purpose. I'm a little bit tired, but I'm not doing this on purpose. 25, 45, 52, 55, 59, 30. Oh, I did two 59s. There's only one, then 30. So I did two 59s. So let me just take this last one, which is a 55. I'll delete it. Put it back up here where that extra 59 is. So I got two 59s. Let's put a 55. Okay, this should be good. Hopefully this is good. Again, do this twice, kids. God bless it. This is so easy to do to make a dumb mistake. Go to menu, statistics, stat calculations. We only have one list. We'll call it X. We click OK. What the heck are you talking about? Cancel. All right, we're going to menu, statistics, stat calculations, one variable statistics. Click OK. Call this X. Boom, I clicked on something too much. All right, so I don't know what they're looking for again. The question says, determine the number of employees' travel time within one standard deviation. So in order to do one standard deviation, you need two things. You need X bar. What the hell did I just write? X bar. And you need sigma X. Now, how do I know it's sigma X and not SX? It never said one population standard deviation. It just said one standard deviation. So do I use sigma X? Or I use SX. Now let's see if this is going to make a difference. X bar is 40. I say we're going to use sigma, which is 14.9. If we used SX, it would be 15.3. And you're going to see that, or 15.4, and that would make a difference. But how do I know it's sigma X and not SX? And that was the tricky part of this problem. Well, it said right here, it surveyed all of its employees. And because it surveyed all of its employees and not a sample, we have to use sigma X. So we'll take the 40, and here's the next tricky part. We're going to add 14.9. So that's 54.9. We're going to subtract 14.9, and we get 24.1. And I'm going to tell you right now, we had so many kids want to go from 24 to 55, but 24 is just a little bit past, and 55 is a little bit past here. So we have to pick the scores from 25 to 54. 55 is just a little bit too much. 24 is just a little bit too little. Now 24, you'll see, wouldn't have made a difference. But you see when we start highlighting that 55 does. 25 we take, 45 we take, 52 we take. Not 55, not 59. 30 we take, 40 we take, 35 we take, 25 we take, not the 40 or the 65, the 29 we take, the 37 we take. So how many scores were there? There were 3, 4, 5, 6, 7, 8, 9. There were 9 scores within one population standard deviation of the mean. Again, that was kind of a tricky one. All right, kids, hit subscribe, hit like, comment. If you need to see more of this, let me know. I'm not sure. I got some more stuff. Again, if you go to my website at mrkrausemath.com, click on Regents Review by topics, and one of these is going to say statistics probably. Statistics right here. So we've got binomial expansion and statistics. There's some more review right there that you can check on if you still need some more help. Catch you on the flip. Bye.